computer, yes. What's up, scholars? Welcome back. My name is Ms. Akin.
My name's Lisa, coming to you from the Indy 500.
And today we're talking about
angles. In our lesson today, we're going to be talking about angles. So if you remember from our last lesson, we learned about the segment addition postulate, in which you have one really big segment and you have little segments within that segment. So that might be helpful to remember today. So instead of segment addition postulate, we're doing the angle addition postulate today. So the way that I think about this is one really big angle with two small angles within it. So if you see here, we're actually given the measurement of our big angle, which is angle STV. Says it's 52 degrees, and then we have angle 1 and angle 2 within this big angle. So since we're given the measure of angle 2, the way we can solve for this is the measure of angle 1 plus the measure of angle 2, which is 24, to equal 52. So from here, you can just kind of work it as a regular math problem. And then once you get that, always remember to write your answer as the measure of angle 1 or 2, whichever one you're being asked for. Just always remember to write the measure of in front. And we get that the measure of angle 1 is 28 degrees. So now let's look at our second example. So in this scenario, we have, once again, a big angle with actually 3 smaller angles inside. The way I think of this to make it a bit easier, maybe label each angle as 1, 2, and 3. This is an option that you have to just make it a bit cleaner with your work if you'd like. So what we're trying to solve is for angle JKN. So we see that our big angle is actually 108. So the way that I'm going to think about this is, okay, 108, and then you see that LKM is actually 70. But the question then is going to be, how do I know how much each small one is? So we actually have an angle bisector, and it's actually represented by segment KN. When you have an angle bisector, it splits those two angles into equal values or equal degrees. So now you can say, okay, so there's an angle bisector and it splits LKM. So now you would just say 70 divided by 2, and you'd get 35 as the value of angle 2 and of angle 3. Then when we want to solve for JKL, you just say, okay, well, I know my full angle is 108, and I know that these two smaller angles are 70. So you could just subtract the values of 108 and 70 and get 38. So we have to realize that our work here isn't done yet because it actually asks for the measure of JKN. So now you have to do is remember your angle addition postulate, add your first angle and your second angle, and then you will get your final answer. So your final answer comes out to be 73 degrees. So now we're going to talk about linear pairs and vertical angles. So first, let's look at linear pairs. So the way you can think about this are just two angles that, I'm so sorry, my parents rang the doorbell. All right, so now let's look at linear pairs and vertical angles. So when we think about linear pairs, I want you guys to figure two angles coming together to make a line. So in this scenario, we have a lot of angles that could be used for this example. So if you look, for example, angle 1 and angle 5 could come together to make a straight line, and those would be considered a linear pair. You could also use angles 5 or angle 6 because they come together to make a line. The idea you just want to remember here is line, which is actually embedded into linear. So now let's look at vertical angles. So the way I think about vertical angles are angles that intersect to make an X. So let's look at our example here on the right, and then you can actually see that these two lines come together to make an X. So when you think about vertical angles, they're actually the angles that are across from each other. So in this example, we could use angle 8 and angle 3, or you could use angle 7 and angle 4. And one key thing to always remember about vertical angles is that they have equal value. So let's say angle 8 is 30 degrees, angle 3 will also be 30 degrees. Same thing for angle 7 and angle 4. If they are across from each other and they are vertical angles, they will have equal value. So now let's look at an example that actually has vertical angles and linear pairs embedded into it. So we're actually given the value of angle 4, and it's actually 137 degrees. And if we see here, angle 2 is directly across from angle 4, so we can say that these are vertical angles. And if we remember, vertical angles are congruent, or they have the same value. So for angle 2, we can say it's 137 degrees. But now we're going to ask ourselves, how do we solve for number 1, for angle 1 and angle 3? So a really, really cool thing about linear pairs is that they actually are supplementary. If they're supplementary, it means that they come together to make 180 degrees. So you could either do 2 and 3 as a linear pair, 1 and 2, 4 and 3, etc. But here in this case, we're going to do 1 and 2 as a linear pair. So we're going to do 180 degrees. So we'll do the measure of angle 1 plus the measure of angle 2 to equal 180. You plug in your value for angle 2, and you solve for the measure of angle 1, and then you will get 43 degrees for angle 1. So we now have solved for angle 1, 2, and 4, and now we're gonna, how do we get 3? So instead of having to do all that math all over again, you can actually just go ahead and say that angle 3 is 43 degrees due to the fact that it's directly across from angle 1, and once again, vertical angles. So now you know that angle 3 is 43 degrees, and you've solved for all 4 angles. So for our very last example, we're going to actually try to solve for variables. So here it says we have to find x and z. We look at our example, we have 2 different pairs of vertical angles, and we have multiple linear pairs. So the way that we're going to want to do this is we're going to want to set 6x plus 50 equal to 8x plus 30 because they're actually a vertical pair. We remember once again, vertical pairs have equal value or are congruent. So now we're just going to want to solve for this algebraically. We'll just subtract 6x from both sides to get x on one side, and then we'll want to subtract 30 from the right side to get our variable by itself, divided by 2, and we will get 10 for the value of x. So now that we have our first variable, we're going to want to find our second variable. So if we remember, like I said last time, when you have a linear pair, you actually know that they add up to equal 180. So in this case, we could do 6x plus 50 plus z is equal to 180. But since we already know our value of 6x plus 50, you can just go ahead and plug your 10 into your x. Once you have plugged that in, you can just go ahead and solve algebraically once again to get your final value for z. So you'll want to add like terms, and then you'll want to subtract your 110 from the left side to get z by itself, and for your final value of z, you will get 70. And that's all you have to do. All right, so let's do our really speedy, what is it called? Review. Really. All right, so let's do a really speedy review on what we learned today. So we learned about our angle addition postulate. If you forget what this is, reference your segment addition postulate. And then just remember, it's one really big angle with 2 or however many smaller angles within it. You just add the angles together to equal your big value. We then went ahead and talked about angle bisectors. So remember that when you have an angle bisector, it splits those 2 angles into equal measurements, makes them congruent. In this case, it was angles 2 and 3 that got equal values. We then went ahead and talked about our linear pairs and vertical angles. Remember that linear pairs are just 2 angles that come together to make a line, and they are supplementary or they're 180 degrees. Always remember that, very helpful when doing math problems. And then finally, our vertical angles. Remember, they're just angles that come together that make an X, and they are straight across from each other, making them congruent in value.
Excellent. All right.
Wait, Miss Akin, you weren't recording. You're recording now.
God.
All right, so let's do a speedy review on what we learned today. So our lesson today was about angles. So we learned about the angle addition postulate. Remember, if you don't remember what this is, you can recall the segment addition postulate, one big segment with little segments. For our angle addition postulate, we had one really big angle with two or however many smaller ones inside. Just remember to add those angles together to equal the value of your bigger angle. Okay.
What is happening?